Alright, in this session, we're going to be looking at implicit differentiation. So, implicit differentiation. Right? Now, what exactly do we mean by implicit differentiation? Now, previously, our examples under differentiation and finding derivatives involved dealing with equations like these. Y is equal to x squared minus 4 summed over x plus 1, things like that. Y is equal to 3 to the minus x times the natural log of x. Equations like y is equal to e to the 3x sine 2x. Now, in each of these equations, we have y being expressed explicitly in terms of x. So therefore, we say that in these equations, y is expressed explicitly in terms of x. However, there are some equations where we cannot achieve this, or where it is just too complicated to achieve this. And so when that is the case, we say that those are implicit functions, or they're defined implicitly, and we proceed to differentiating as they are. Right? So we're going to be dealing with equations where the y term simply cannot be separated from the x terms, or is just too tedious to do that. And when that is the case, we apply implicit differentiation. So we're going to look at some examples. So the first example, let me jot down a few examples. It says that find dy by dx for, and the first one is given as 3x squared y squared plus 4x is equal to 6. And the second one is given as 6x squared y plus 2x squared y squared is equal to 4xy. So let's focus on those two for now. Right? Now let's deal with the first one. So here we have 3x squared y squared plus 4x is equal to 6. And clearly that function is not defined explicitly in terms of where y is explicitly expressed in terms of x. So we have to apply implicit differentiation. Now, how do we go about doing this? Now, basically, we have to differentiate both sides with respect to x. So we're going to say that d by dx of 3x squared y squared plus 4x is equal to d by dx of 6. And we proceed. Now, inside the brackets, we have 3x squared y squared, which of course is a product, and we have a simple term in x, 4x. So for this part, we basically have to apply the product rule. So let's proceed. When you differentiate 3x squared y squared, if you recall, let me just jot it here. If you have a product, uv, we say that d by dx of uv is equal to u dv by dx plus v du by dx. So this basically is the product rule of differentiation. And occasionally, we may need to apply a combination of the product rule, chain rule, quotient rule, and so on. Right? So let's proceed. So when you differentiate 3x squared y squared, to keep the first part, so we say that this is 3x squared, and we're going to be multiplying that by the derivative of y squared. Now, when you differentiate y squared, what do we get? We treat it as a regular derivative, we bring the power down, so 2 comes down, y, the power decreases by 1, and then of course, because we are differentiating a function of y with respect to x, we multiply by dy by dx. So the derivative of y squared with respect to x is 2y dy by dx. So we close that. Second part is going to be now plus y squared times the derivative of 3x squared. When you differentiate 3x squared, what do we get? We get 6x. So that is plus y squared times 6x. Now we have to differentiate this term plus 4. And that of course is equal to 0 because the derivative of 6 with respect to x is simply equal to 0. So what do? We expand the brackets and we try to simplify and of course make dy by dx a subject. So we get 3x squared times 2y, that gives us 6 x squared y dy by dx plus 6x y squared plus 4 is equal to 0. And because we need to find dy by dx, we need to bring these terms over to the next side and make dy by dx a subject. So we say that 6x squared y dy by dx will be equal to minus 6xy squared minus 4. And lastly, we get that dy by dx will be equal to minus 6x y squared minus 4 all over 6x squared y. And there we've managed to find dy by dx for this implicit function, right? So that is the first one. Now let's look at the second one. Second one, we have the implicit function again. This one is 6x squared y plus 2x squared y squared is equal to 4xy. So let's write it here. We have 6x squared y squared plus 2x squared. Whoa, what did I write here? So no, this should be 6x squared y. 6x squared y. No squared in this first one, right? So 6x squared y plus 2x squared y squared is equal to 4xy. Again, we have each term in the equation is basically a product. So we'll have to apply the product rule to each term essentially. So of course, we're going to say that we're going to differentiate both sides with respect to x. So we can say that d by dx of the left hand side, which is 6x squared y plus 2x squared y squared is equal to d by dx of 4xy. Right? That is what we're basically doing there. Now we proceed. So again, because 6x squared y, that's a product, we can let this be our u, that be our v. Similarly, this is another product, so that can be our u, that can be our v. 4xy is also another product, so that can be our u, that can be our v. Right? So let's proceed. Now, the 6, of course, is a multiplying constant, so we can keep the 6 outside, but let's just differentiate the entire thing as 1, right? Because we are going to have a few brackets, so let's try to have as few brackets as possible. So, based on the product rule, it's going to be equal to the first times the derivative of the second. So this is going to give us 6x squared times d by dx of y, right? Then, of course, it's going to be plus y times d by dx of 6x squared. And that right there is the derivative of the first term in this bracket on the left hand side. So we're going to say now plus. So this part u is taken as 2x squared. So this is plus 2x squared times d by dx of y squared. Then you have plus y squared times d by dx of 2x squared. Right? All of that is just the left hand side. So this time I'm actually showing all the steps in the breakdown of the derivatives. And then of course now that is going to be equal to 4x times d by dx of y plus y times d by dx of 4x. So now we can actually go ahead and do some little simplification. So in this first term here we have 6x squared dy by dx. Then we have plus, when we differentiate 6x squared, we get 12x. And so we're going to multiply that by y to give us plus 12xy. Then we say that when we differentiate y squared, that basically becomes 2y dy dx. So this becomes 2x squared times 2y dy by dx. Right? And of course, still going to become this term now plus the derivative of 2x squared, that is going to be 4x. So 4x times y squared, that gives us plus 4x y squared. And that is the derivative of the left hand side. And this is going to be equal to 4x dy by dx plus, now the derivative of 4x is just 4, and of course you have to multiply y by that. So this is plus 4y. So having done that, we can proceed. So let's write this another time. We can write 6x squared dy by dx plus 12xy plus, this right here is 4x squared y dy by dx plus 4x y squared is equal to 4x dy by dx plus 4y. Now the next step basically is to group all our dy by dx terms and essentially factor out dy by dx. So let's scroll a little bit. No, let's not scroll here. Alright, so so let's look at how many terms we have in dy by dx. We have one right here, that is in dy by dx. We have another one there, and we have another one over here. So basically all the terms of course must be brought to the same side. So all the terms must be brought to the same side, and let's do that. So we'll take this one over and bring it over. So this becomes 6x squared dy by dx plus 4x squared y dy by dx, and we're going to bring this over, so it's going to become minus 4x dy by dx, and of course all the other terms must be taken across to the right hand side. We already have 4y over here, so we'll keep that. So we get 4y. When you bring the plus 12xy across, it becomes minus 12xy. When you bring the 4xy squared across, it becomes minus 4xy squared. Now from the first three terms, you can factor out dy by dx. So we get dy by dx, open bracket. This is 6x squared plus 4x squared y minus 4x. And this is equal to 4y minus 12xy minus 4xy squared. Having factored out dy by dx, then you can simply divide both sides by this expression inside the brackets, and so we get that dy by dx is equal to 4y minus 12xy minus 4xy squared all over 6x squared plus 4x squared y minus 4x. And there we have the derivative dy by dx of that implicit function, right? So dy by dx equals 4y minus 12xy minus 4xy squared all over 6x squared plus 4x squared y minus 4x. Now let's look at another example. This time we're going to look at this one. This one says so find dy by dx 4. So let's write on the function. We have 7x cubed plus 4y, that is equal to 3y squared. Now this one is less complicated because it doesn't have any products. In each term there's a single variable raised to a particular power. So basically we're going to say that d by dx of the left hand side, which is 7x cubed plus 4y, is equal to d by dx of 3y squared. So when you differentiate this, what we get is this. We differentiate the first term. This is just a multiplying constant 7, and we keep and of course you're going to differentiate the x. So we keep the multiplying constant, so this becomes 7 times. When differentiating a power of x, we bring the power down, multiply by it, and reduce the power by 1. So that becomes 3x squared. Right? Plus 4 dy by dx is equal to 3, and we differentiate 2y squared, which gives us 2y dy by dx. Alright? So therefore, we get 21x squared plus 4 dy dx is equal to 6y dy by dx. And so basically we must group all our dy by dx on the same side, so we can bring this one across. You get that 21x squared is equal to 6y dy by dx minus 4 dy by dx. So now we have the dy by dx terms on the left hand side. We can factor it out. We can factor out dy by dx. So we get that 21x squared is equal to dy by dx bracket 6y minus 4. And this therefore means that dy by dx is equal to 21x squared all over 6y minus 4. And that is dy by dx for that particular implicit function. Right? Let's look at another example.